Good morning, everyone. Good morning. Hope all is well. Just waiting for everybody to get in, and then we'll get rolling.
I had a quick question.
Yep.
I did the chapter 2 test and I was trying to go over the questions that I got wrong.
Mhm.
I guess I clicked off of it and now I can't view it. Is that just how it is? Once you click off, you can't go back and view your test scores?
Now you're supposed to be able to go in there freely just to review. So did you go through your grade book and then go through, like, look at your scores and then click on it then from there? Because I know if you go and try to click on it through one avenue, you can't click on it. But then if you go through another avenue, like your grade book, I believe it's your grade book, you should be able to click on it.
Okay, I'll try that. I didn't try that part.
Okay. All right. Sounds good. So good morning, everyone. Hope all is well. Hope everybody's doing okay. I hope everybody had a great weekend. I had a rough one, to say the least. So if you send me an email, I am behind. I've been dealing with a daughter who's been throwing up and all types of stuff, So yeah, it's been kind of tough on my end. But if you send some emails, give me a chance. I'll get to them before the day is out and get caught up on that. So let's go ahead and get rolling. So we're going to look at 3-3 today. Last class we did 3-1. I will double back and do 3-2 if we have time. But I like to go ahead and knock out, the whole section and then see if because 3-2 is not really that big a deal. So we can go to 3-3, spend time where we most definitely need it, and go from there. All right. So dividing polynomials, the remainder theorem, and factor theorem. All right, so I'm going to erase some of the stuff down here so we can walk through the process of long division. I know you guys know this, but this long division process is the same process that we're going to use when dividing polynomials using long division. So I just wanted to re-emphasize how you would roll when you have the long division process that you're trying to implement. So 5867, 5,867, we want to divide that by 11. Notice the position of your division. 5,867 goes under your divisional sign. And then your divisor is 11, and that goes on the outside. All right. So now you're comparing 11 to 5. 11 doesn't go into 5, but it goes into 58 5 times. Then you take because that's the largest number that 11 can produce. That's under 58. Then 5 times the 11 gives you 55. I want to be green. Subtract. So 58 minus 55 is 3. Bring down 6. Bring down the next digit. Then you say, how many times does 11 go into 36? And that'll be 3. Then 3 times the 11 is 33. Subtract 36 minus 33 is 3. Bring down the next digit. And it's 37. How many times does 11 go into 37? 3 times. 3 times 11, once again, 33. 37 minus 33 is 4. That number that we have last or left is our remainder. We're not adding, decimals or anything like that. So this is the end of our problem. So that lets us know that that is our remainder. And notice how we write our answer is 533. Then we take the remainder and place it over what we were dividing by, which was 11. So this same long division process is what we're going to implement with dividing our polynomials. All right, the subtraction to bring it out to digits, all that. Scroll up, everybody good? All right, so we want to divide x squared plus 10x plus 21 by x plus 3. I'm going to erase some of this stuff so we can walk through it. Is everybody done with the last problem? All right, so we set it up the same way we set up the last, that long division problem, wherein our x plus 3 is sitting on the outside of our divisional bar. X squared plus 10x plus 21 is under it or on the inside. So you compare the first terms in each, x and x squared. Say how many times does x go into x squared, or what does it take to turn x into x squared, or x squared divided by x, whatever way you want to look at it. That's this right here. X squared divided by x is x. And so that's what the first part of our answer. What times x will give me x squared is x. And normally you line up, x, the powers of x with the power of x. Notice I put x over to 10x. You don't necessarily have to because all of this is reserved for your answer, but normally you line them up and that way you'll get to the end of your problem at the same time and you know when you're done. All right. So x is the first part of our answer. Now we're going to take that just like we did with the 5. We multiply it to each term out here, just like we did 5 times 11. So x times x is going to give me x squared. X times 3 is 3x. Now we have to subtract. Notice I put parentheses there. Make sure you're subtracting both terms. So these cancel. And this is now 10x minus 3x, which is 7x. So make sure we're okay with what happened. We compared the first terms in each. We had x and x squared. And we said, what times x will give me x squared? And it was x. So that's the first part of our answer. We take that and multiply it to each term out here. And it gave me what was down there in the purple, x squared plus 3x. Now you subtract. The x squared is canceled. 10x minus 3x is 7x. Just like when we did a long division process with just numbers, the next move is to bring down the next term. So bring down plus 21. Once again, compare the first terms in each now. X and 7x, what times x will give me 7x? And it's just 7. That's what goes up here. Take your 7 now, multiply to each term out here. And that is going to be 7x plus 21. Go ahead and subtract. 7x is canceled, 21 is canceled, and that leaves you with the remainder of 0. So our answer is just x plus 7.
How did the negative get placed at the bottom with the parentheses again?
All right, let me make sure I got which one you're talking about. This one right here? You said, hold up.
Yeah, that's the one.
All right, sorry if you were shaking your head for some reason. I don't know what's going on, but now when I have your class, like when I start writing, you guys disappear until I click on another button to make you come up. I'm gonna see if I can fix it, but if you shake your head, I won't see it unless I bring you back up. But yeah, that's part of the process. So let's go back to here. Notice how we have a minus sign each time we go throughout our progression. That minus sign is a part of the process. All right. All right, anybody else, anything else before we do another one? I know y'all can't wait to do some more. Can we also factor them out and cancel? Yes, you can when we're going to get to factors and stuff. But if you're just doing the long division process, you know, factoring and canceling and long division process are two different things. That does help in this case, but it only helps when your remainder is zero. So if it's not a factor and you're going into our factor theorem and our remainder theorem, so we're going to get there in a second. So you're a little bit ahead of us. But yeah, that only works if x plus 3 is actually a factor of the polynomial you're dividing into, but that is a way to do it as well. Yep.
I got it.
Mhm. Good insight. Good insight. All right, somebody else is coming. Okay. All right, let's scroll up. Let's do another one. Here we want to divide 4 minus 5x plus, not plus, minus x squared plus 6x cubed by 3x minus 2. So just like before, let me erase some of this stuff so we can walk through it. So notice the first thing I did while I'm doing this erasing is that I went ahead and rewrote our dividend in descending order. It was 4 minus 5x minus x squared plus 6x cubed. Rewrote it in ascending. No, it was written in ascending order. I rewrote it in descending order, just to match what we normally do and to match our divisor. That's written in descending order. So you want both pieces to be written in descending order, just to match the process that we normally hold true to. All right, and also make sure that whatever's negative stay negative, whatever's positive stay positive. Notice 6x squared is still positive, 6x cubed is still positive, x squared is still negative, 5x is still negative, and 4 is still positive. All right. Everybody good, everybody straight. So now we got a whole, excuse me. Now we have to follow the process that we did in the last one. We're going to compare the first terms in each, 3x, 6x cubed. What times 3x will give me 6x cubed? Or in other words, 6x cubed divided by 3x, whichever way you want to process it. And that is going to be 2x squared. Once again, lining up my x squareds. Take the 2x squared, multiply it to each term. That's going to be 6x cubed minus 4x squared. From there, subtract both terms. Now, keep trying to emphasize that because a lot of people, if they're going to make a mistake, they make a mistake right there. They'll just give the negative to the 6x cubed and forget to give it to the 4x squared. And then next thing you know, everything from that point forward will be wrong because that minus sign has to go to each term. So make sure you're careful with that. So 6x cubed cancel. It's supposed to do that. Then we have negative 1x squared plus 4x squared, which will give me a 3x squared. Bring down your minus 5x. Now comparing first terms again, 3x and 3x squared. What times 3x squared will give me, what times 3x will give me 3x squared? And that's this right here. All right, so that'll just be x. X times 3x will give me 3x squared. Once again, multiply to both. All right, so 3x times x will give me 3x squared. X times negative 2 is negative 2x. Once again, distribute the negative. Negative 5x plus 2x is negative 3x. Bring down your 4. Compare first terms in each again, 3x, negative 3x. That'd be -1. Take that -1, multiply it to both. That thing raised. There we go. So that'd be -3x plus 2. Distribute the negative. That turns into a -2. So we have a remainder of 4 minus 2, which is just 2. And this is how we would write our answer. So we have 2x squared plus x minus 1. And that remainder of 2, you write that 2 over 3x minus 2, which is what we're dividing by. Any questions before we go to the next one? All right, let's do another one. Now this next one, notice that we have x to the 5th plus x cubed minus 2 over x minus 1. So what we're going to do here is use some placeholders for the missing terms. You know, we look at it as a progression. Notice that we're missing x to the 4th, missing x squared, and missing x. So we need placeholders for those variables that we're missing. And all that does is, like it says, hold a place for us to be able to go through our progression without having to worry about skipping terms or anything like that. So it just helps us in our progression. All right, so notice what we did here. I use 0x to the 4th, 0x squared, and then 0x. All right, 0 times anything is just 0, so we haven't changed the value of anything. That just, once again, holds the place so we can go through our progression the same way we would any other problem. All right, any problems? All right, let me erase some more of this stuff. All right, so was everybody done with this before I scroll all the way up? I don't want to see that. All right, so as we did before, we compare the first terms in each. What times x will give me x to the 5th, and that is x to the 4th. So take the x to the 4th, multiply it to both down here. Of both of us on the outside, that's going to be going to give me x to the 5th minus x to the 4th. Distribute that negative. So these will cancel, and then x to the 4th plus 0 is just x to the 4th. Bring down x cubed. Then you say what times x will give me x to the 4th. That's just x cubed. X cubed times x to the 4th, x cubed times -1 is negative x cubed. Did I hear somebody unmute? Is everybody okay?
My question.
Okay, cool.
Can you go over that for like one more second? I yawned.
Look, man, what
I
we're not
yawned
gonna
and then I
do.
was like, I was expecting to be x to the second squared.
Uh-huh.
So x times that. Okay. Okay, I see it now.
Look, man, you're not gonna hold up the class because you yawning, man. You already laid back, relaxing. You need to throw some caffeine in the process. Yes,
I
sir.
can't afford to lose height.
Oh, that's what caffeine does?
It makes you shorter.
I didn't know that. But going back to the part, I assume this is where Mr. Bracy yawned. X cubed, we multiplied it to both terms, and that'll give me x to the fourth, and then times -1 x cubed. And where we got that x cubed from is that, once again, we're comparing the first terms in each. We have x and x to the fourth. So you say, what times x will give me x to the fourth? And that is this x cubed. And so you multiply that to each.
Why isn't that x to the fourth that you just circled not negative? Because up above it, you have, when you distributed your negative sign, you had to distribute the positive. So you have a positive over a -4. Yep. So why isn't that -4 plus
Right,
x3?
Yeah. So now we just originally, this is what we had when we distributed this x to the fourth, that gave me x to the fifth, and then x to the fourth times this gives me negative x to the fourth. And so now a part of the process is to subtract. So now when I distribute this negative, that's x to the fifth minus x to the fifth, which cancels. Now here we have a negative to a negative, which turns it positive.
Oh, okay.
Yeah.
All right. Okay, I see it now. The blue is a different color, so you're trying to show that it's okay. I'm with
It's
you.
changing.
Got it.
Yep.
I got it.
Yeah. Questions before we go to the next one? Everybody good? So going back to the same thought process that Mr. Williams brought up, now we're going to subtract each one of these terms, and then the signs change again. These first two are supposed to cancel, x to the fourth minus x to the fourth. Then we had a negative in the parentheses, so that negative to negative turns positive. So we have x cubed plus x cubed, which gives me 2x cubed. So it's going to be very important that you guys watch these signs and be careful, because it's easy to mess up. A lot of times, like I said before, that's what I'm trying to emphasize, this the distribution of the negative. A lot of times people will just give the negative to one of these terms, and then, like I said, after that, everything's messed up from that point forward, because you have to give the negative to each term that you have down there. All right, so then bring down 0x squared. Yeah, I got another one. Try to see something real quick, guys. Okay, sorry about that. Bring down 0x squared. And you say, compare your terms. We have x and x, 2x cubed. What times x will give me 2x cubed? And it's going to be 2x squared. Once again, notice how my terms are lining up. X to the fourth, x cubed, x squared. That's how it's supposed to work. If you start off correctly, that should be a hint as to what your next one or your next variable exponent should be, and all that good stuff like that. So it's going down in a progression. So 2x squared times x and times this -1. So that's 2x cubed minus 2x squared. All right. So 2x squared times x is 2x cubed. And it's minus 2x squared. And we'll distribute this negative. That's going to be plus 2x squared. 0 plus 2x squared is 2x squared. Bring down your 0x. Comparing your two terms, x and 2x squared, what times x will give you 2x squared? And that's just 2x. 2x times both of those. That's 2x squared minus 2x All right, distribute the negative. Those cancel. Now you have 0 plus 2x, which is 2x. Then what times x will give me 2x? That's just 2. Then multiply 2 to both of these. That'll be 2x minus 2. And each one of those will cancel out once you distribute, giving us a remainder of 0. So that will be the whole problem right there. Any questions? Any questions? All right. Everybody good? Go to the next one. Anybody still copying? Okay. So that process is the same. It holds true. So try it out. See if you get stuck. If you get stuck on any of the steps on those processes, in that process, excuse me, then make sure you bring it to class so we can walk through it. So that's long division. The other type of division in this section they talk about is synthetic division.
You show the answer. It's not 0, right? It's like this.
Yeah, up here.
Okay.
Yeah, since it didn't have a remainder, that is your answer. Before, it had a remainder, so you need to write it with the remainder.
Divided by the
divided by
multiply thing.
Yeah, whatever you're divided by. Yep, your divisor. Since this didn't have a remainder, that's your answer right there. We should burn them all. such vitriol pointed towards mathematics in this classroom. All right, so everybody good? Okay, so let's look at synthetic division. So now you can only use synthetic division when the divisor is in the form of x minus c. So in other words, that means the coefficient of x is 1, the number in front of x, that's your coefficient, that is 1. And the highest exponent on your variable is 1. So that's the only time you can use synthetic division. All right, and it has to be in this form, x minus c or x plus c. It's the only time you can use it. So first example in green, just an example of when you can use synthetic division. Load divisor is x plus 2, so you can use it. The second one, x squared plus 2 is in my denominator. It means I cannot use synthetic division. And then in the third one, 2x plus 2 is in my denominator, so I cannot use synthetic division. So this has to be the case in order for us to be able to use synthetic division. All right, can I scroll up? Everybody good? All right, so let's talk about how we're going to set this thing up. So we have x minus 3. We're dividing that into x cubed plus 4x squared minus 5x plus 5. And we want to use synthetic division. Somebody want to scroll up some? Okay, no, that's not it. All right. Can you scroll up? Good. Okay, so notice the first thing is that inside of that little box to the left, you use the opposite sign of the number that's with x. All right, so we have x minus 3, so we use plus 3 or the positive 3 in that box. And then we use all of the coefficients of our dividend. So that's 1, 4, -5, and 5. Make sure you hold true to positive and negative signs. All right. First step is to bring down 1. And then we're going to take this 3 and multiply it to that 1. And the result we're going to put right here. Add these numbers together. It's going to be 7. And then we're going to repeat the process till we get to the end. So then we're going to do 3 times 7, which is 21. Add. They give me 16. And 3 times 16 is 48. Add. That's 53. Problems with the process.
Can we go over that like one more time? It wasn't even me yawning. I looked at that, but I didn't understand a single bit.
And can you scroll down a little bit?
All right, you want to scroll down?
Like scroll down to see the green things, or
Yeah, what do you need?
No, like I can't see the whole problem. It's like it's cut in half.
Okay. Got that?
Yeah.
All right. So once again, just walking through the process. So you bring down the 1. The first number, whatever this is, you bring that straight down. Then you take this number out here and multiply it to the number down here. Whatever that result is, you put it here. Add them. That'll give you that 7. And then once you do that, you just repeating the process. 3 times 7 is 21. Add them together, that's 16. 3 times 16 is 48. Add them together, that's 53.
gotcha.
All right. Is everybody good before we go to the next step? Make sure we're all right. First move is to bring down that first number. Then you multiply that times the number in the box.
I don't know if it's just me, but I'm just not getting how the whole green numbers are being achieved.
3 times this number times this number.
What's this number?
Oh, you can't see this, my circles? Sorry about that. 3 times 1. Sorry, can you see them now? Okay, cool. So I probably just using the black probably didn't help. Yeah, so 3 times 1 gives me the 3. And then from there you repeat that same pattern. 3 times 7 gives me 21. And then 3 times 16 gives me 48.
But you get to that 7 by adding that 3 plus 4. You add that number plus the number above it.
Yeah.
So
yeah, these numbers are always,
The 4 is coming from the 4x square.
yes.
Well, what's happening to the x square?
We ain't got to that part yet. Yeah. We haven't gotten to that part yet. So we're about to go. That's the next step. But we just try to make sure we're okay with getting these numbers, because if you don't get the numbers right, it don't matter. It don't matter how many x squares you have, you know what I mean? So we gotta make sure we have the right numbers. So before we go to the next step, is everybody good with these numbers? All right, notice I wrote here in purple that that last digit is always going to be your remainder. That last part of the process. So we have these numbers down here, 1, 7, 16, 53. That last number will be your remainder. And notice I wrote in red, you start with one exponent less than the original polynomial. We had originally x cubed. So we start with x squared and we use all of these. So we use all of these and write them here. So that's why we have 1x squared plus 7x plus 16x. And then we have 53 over x minus 3. Remember, 53 is your remainder.
There's no
So-
x on 16.
Yeah, because we started with x squared.
Okay.
Then it go x, and then there's no x. Yep.
Okay.
That's the answer.
Yep.
That was quick.
Yeah, synthetic division is quick. Once you catch the pattern, it's very quick. You don't have to use long division if you don't want, because you'll still get the same answer. The only problem is you only can use it when you're dividing by this type of expression. If there's something in front of x, or if there's an exponent other than 1, you cannot use synthetic division. But yep, synthetic division is pretty quick.
So this one is the shorter version of the previous one.
Exactly. Mhm. All right. Any problem before we do it again? Let's scroll up. Everybody good? All right. So the next one, we got 5x cubed plus 6x plus 8, and we're gonna divide that by x plus 2. So don't forget, we're gonna use the opposite sign. So there's two things going on here that we gotta make sure we hold true to. In our little box, we're gonna use the opposite sign. Yep, I had my eraser still on. Use the opposite. Hey, what in the world? Come on, man, eraser work. Oh, get off. Anyway, use the opposite sign of this. That's why we have -2 in the box.
Why do we use the opposite?
Well, we'll get there in a second. We'll get there in a second. But right now, we're just making sure that we hold true to the process. And I'll show you in the next thing, we're gonna talk about why we use the opposite sign.
And when it say missing terms, what does that really mean? Like, I understand you plugging in the 0x, but like, what is it like? What is it doing?
So notice how we got x cubed, and then we have x to the first power.
Uh,
And you look at between them, what number is missing? It is
Squared.
Yep, that's squared. So that's what we're talking about right there.
Okay.
Yep.
Okay.
And so, yep. So you want to give an account for that. Any missing term that you have, if you looking at the numbers of your exponent and it skips a number, then you want to give an account for that. And that, like she just mentioned, is x squared. So you put a 0 there for x squared. And then we have 6 and 8. So it's 5, 0, 6, and 8. Let me see. What's this in the chat? Yep. All right. Any problems? Everybody good? All right. So now we follow the long division process. First step is to bring down 5. All right. Now, -2 multiplied to the 5 is going to give me a -10. Add those together. So that's 0 plus -10, which is just -10. -2 times -10 is +20. Add those together. 6 plus 20 is 26. Then -2 times 50, I said 52. -2 times 26 is 52. -52. And then adding them together gives you a negative 44. And that gives us this answer right here. 5x squared minus 10x plus 26 plus negative 44 over x squared, x plus 2, excuse me. So once again, you start off one exponent less than what you originally had.
I have a question.
Mm-hmm.
So with significant division or whatever it is, synthetic division,
Mm-hmm.
There can't be a coefficient for x, right?
Right.
My question is, why is that? Because like, if you're just solving for x and then plugging that in, can't you just divide the like say for example, this was 2x plus 2. Couldn't you just say put the 2 over there, divide it by x and get 1?
Well, that's not in the form now. If you converting it to that form, then that's a different story and a different topic, and you're adding a step to the process. So
But it's
now
possible.
it's possible. You just have to make sure that because let's see, because you can do that, and that's fine. That's because you're solving. But you just have to be careful that you don't take that same thought process and say, if I have this, then that means I should be able to solve for it, and do it like that, because now you're really stepping into some dangerous territory trying to apply that same way by just solving for X. So right now we're just talking about the basics of what you're presented. What can you do with what you're presented? And then, and then from there, once you start looking at, okay, the ins and outs of what you can do, then you can start playing around and seeing how, okay, this works, this doesn't work type stuff. Right now, just doing basics and making sure everybody okay with it. When I see this, I can use it. When I don't see this, I can't use it. You know what I mean? So yeah, that's pretty much, once you have insight on what you're doing, then yeah, you can do stuff like that.
Gotcha.
All right. So let's take this synthetic division and add an extra step to it. This is going to get into what your classmate mentioned about why we're using the opposite. So the remainder theorem says if the polynomial f of x is divided by x minus c, then the remainder is, you take the opposite number. Notice we have x minus c right here. But if we take plus c, plug it into our function, that will be the remainder. So I'll give you a chance to write down the remainder theorem, and then we'll talk more about it. All right, so it says given the f of x is x cubed minus 4x squared plus 5x plus 3, use the remainder theorem to find f of 2. Now, when we've had the expression x minus c or x plus, let's say x minus 1 or x plus 2, like we did before, we use the opposite number. But if they just give you f of 2, then all you would do is use it. So the only time you use the opposite is if they give it to you with x. And that goes back to what I was talking about with your classmate. Notice how they gave us x plus 2 here. Why are we using the opposite? Because if we were to solve it, then we would do minus 2 to both sides, and x would be equal to -2. And that's going to connect to our next theorem as well. But whenever they give you the expression like this, that's when you use the opposite. But if they give you f of 2, you use the number that they give you. Okay, so here I was just showing you the difference. So if they give you x minus 2, then that's the same thing as f of 2. If they give you f plus 2, x plus 2, that's the same thing as f of -2. So if it's with x in this form, you use the opposite in that box. Once again, if they just give you the number like f of 2, or they say 2 is a solution, you're going to just use that number that they give you. Okay. Questions on when we use opposite, when we wouldn't use opposite. Once again, you use the opposite when it's with x like this. So if they give you x minus 2, then that means I'm going to put 2 in the box. But if it's not with x like that, and they just give you the number, whether it be they say 2 is a solution, or if they say f of 2, you just use the number that they give you. All right, so is everybody good with that before we go through the process of synthetic division? So what we're going to do here is we're going to do synthetic division, then we're going to plug in the value. If the remainder theorem is true, then both of those numbers should be the same thing. All right. So synthetic division, we have 2 in the box, and we have 1, -4, 5, and 3. Bring down 1. It's always the first move. Bring down the first number. Then 2 times that 1 is 2. The result goes here. Add them together. -4 plus 2 is -2. 2 times -2, -4. 5 plus -4, 1. 2 times 1 is 2. 2 plus 3 is 5. Yes. If you were to write it out, that 5 would be over x minus 2 when you write down your answer. Now we didn't, we're not going there this far because all we're doing is testing the remainder theorem. But yeah, if you had to write out your answer, that's what it would be. That's what it would be. So now if this holds true, the remainder theorem says that if I were to plug in 2 into my function, I should get 5. And so that's what we did right there. So I plug 2 into the function. That's 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3. And then when you simplify that, notice you get 5. So just letting you know that once you plug that number into the function, that is your remainder as well. So that's going to be a test that we can use for the next thing that we're looking at.
So you plugging that 2 back in was just to confirm that 5 was your remainder?
Well, it's just to confirm the remainder theorem and how the remainder theorem works. Yeah.
So the whole point of the remainder theorem is to, when you plug that number back in, is to make sure that the remainder is the same on both sides.
Not necessarily to make sure, but to establish what the remainder is, because that will dictate what I do next. And we're about to get into what I mean in a second.
Okay.
Yep. But you're not necessarily it's not necessarily confirming what the remainder is, but to establish, okay, what is the remainder here? Because if I know the remainder, then I'll know how to move next. And so getting into that, just terminology, if you see the word solution, 0 or root, they're the same things, they're interchangeable. And the reason why our solutions are called zeros is because the remainder is 0 when you plug them in or when you do synthetic division. So that's how they're connected. If I'm looking for solutions, if I plug this value into my function and I get 0 out, then I know that's a solution for this function, because that means the remainder is equal to 0. Which takes us into what T-Rex was mentioning earlier.
Can I ask you to say that one more time, just because I was writing that down as you were saying it?
Oh man, it's gone now.
All right, cool.
So solutions, zero, and roots, they're interchangeable. They all mean the same thing. In your calculator, I know in the TI, they used to say roots. Your book in this chapter uses the term zero. And up to this point, we've been calling them solutions. So when your book mentions zero, they're talking about solutions. Just another way of calling a solution a solution. And the reason why they call them zeros is because the remainder is zero when you plug them in. Going back to what you were asking about, well, what's the purpose really of doing the remainder theorem? Well, if I plug a number in that I think might be a solution, if I plug it into my equation and I get zero out, then it is a solution. And so that's how that would be beneficial to me. And it will let me know if I can progress further with that number based on the fact whether it's a solution or not.
So basically, when you're back up with the equation where you plug the 2 in, if you didn't want to go through that process of doing the synthetic division, then you could just plug a number in the theorem and see what you get. And if it results in a zero, then it's a solution.
Yes.
Okay.
And then it will let me know if I need to do synthetic division with that one, because in the next section, we'll be looking to break down equations. But I can do it by doing synthetic division and seeing if I get a zero, or I can plug in value into the equation and see if I get a zero to know if I need to do synthetic division. So, yeah.
This is kind of like a bridge.
Yeah. Yeah.
I got you. Okay.
Yep. So the factor theorem, just telling us if you have f of x as our polynomial, going back to what we were mentioning with Mr. Williams, if I plug a value into my function, I get out zero, that means that x minus c is going to be a factor. Or if x minus c is a factor, that means that when I plug c into it, you get zero. So just saying the same thing, but different ways. If you figure out that f of c is equal to zero, that means f of x minus c is a factor of f of x. But if x minus c, if I can get it out, is a factor of f of x, that means f of c is equal to zero. And so just to establish, make sure we're okay with what it means to be a factor. Show you that example in a second. Just reestablishing what it means to be a factor, but giving you guys a chance to write that down. All right, so don't forget when you're factoring. Oh, what happened there? Okay, when you're factoring, when you break it all the way down, those are called your factors. So if I have x squared plus 7x plus 10 equal to 0, and I break it down by factoring, I have x plus 5, x plus 2. Those are my factors. X plus 5 and x plus 2 are my factors. Now to get my solutions or my zeros, I subtract 5 from both sides in the first one, subtract 2 from both sides in the second one, and I get my solutions, or once again, my zeros. Those are the numbers that if I were to plug them into x squared plus 7x plus 10, it will equal to 0. And if I were to divide them, my remainder will be 0. All right, and I just emphasize that right here, just showing you plugging in -5, I ended up getting 0 out. All right, problems with that. What was said?
So you basically solve the left side of the problem and then just put an equal sign in between it, and then the solved part of the left side of the problem is now on the right side of the equal sign. And you
Okay,
said, is that right?
Let me make sure I understand what you're saying. So you're talking about right here?
Mm-hmm.
Yeah.
No,
So,
down where you plugged in the x minus 5.
oh, okay, right
So
here.
it looks like you solved the left side of the equation, put an equal sign there, and then put 25. So it looks like you solved the problem, just put an equal sign in between. Is that correct?
Yeah, that's all I was doing, was simplifying it,
Okay.
because that was going back to I was just using this. So we're talking about our function being x squared plus 7x plus 10. And I just plug 5 into it just to show that, yeah, we would get 0 out, which connects back to the fact that -5 is a 0.
Okay.
Yeah. Yeah, just re-emphasize, just showing you, instead of just saying it, just showing you what we're talking about. Yeah.
I get you, but like when I hear you, but I'm writing down, but then I look up and I'm like, wait, what? But
It's all good.
I'm getting it now.
Yeah. And so the same thing would happen if we were to plug in -2. If we were to plug in -2 into this function, it would still equal out, give us 0. All right. Everybody good? Can we try one? Okay. So first example, under this type of thought process, we want to solve the equation. We have 2x cubed minus 3x squared minus 11x plus 6 equal to 0. And they tell us that 3 is a 0. So now, for most of us, factoring this wouldn't be really an option in its current state. But we have the information that 3 is a 0. So what we can do is use 3 to break down this equation into something that's factorable, or into a quadratic equation, so I can use my quadratic formula. So whichever way. So notice that since we know that 3 is a 0, that means that, those 3 things, notice what I pointed out, that means x minus 3 is a factor. Because remember, it's the opposite sign. X minus 3 equals 0, add 3 to both sides. That's how you get your solution. That means if 3 is 0, that means 3 is a solution. So when it says solve for 2x cubed minus 3x squared minus 11x plus 6, I already know one of my solutions. All right, 3 is one of my solutions. So notice it says we're supposed to have 3 solutions because x cubed. I already know one of my solutions. So don't forget to include that as a part of your answer. When in math lab, they ask you to solve and they give you a solution, don't forget that is one of your answers. They will mark it wrong if you only put the 2 that you find, because 3 is one of your solutions as well. So make sure you hold true to that. And then f of 3 is equal to 0 as well. If 3 is a 0, that means when I plug 3 into my function, I get out 0. So those are the 3 things that you know when you see 3 is a 0.
So in my math lab, are we just supposed to put commas in between each one of those answers, or is it going to be like a 1-part question is for one, then the next part question is for the other type situation?
If I remember correctly, they just give you one box and then you put commas in between each one of your answers. All right, so we're going to use synthetic division to break down the function. And this goes back to what Mr. Williams was saying. This is why this is important. Let's say if they didn't know and you had to test it, you would plug 3 in and get out 0. Then you can use 3 to break down the function. We already know it because they tell us that 3 is a 0. But let's say if you was doing this from scratch and you wanted to know if 3 was a 0, if 3 was a solution, you would plug 3 in and see if it equals to 0. If it is the case, then you can use synthetic division to break down the function. So that's what we're doing here. I'll erase this just to walk through the process at least one more time to make sure we're all right. So 3 is a 0. So once again, that's the number you use. The only time you use opposite if it said 3x plus 3. If it's like this, then you use the opposite number. But they tell us 3 is a 0, so we're going to use 3. All right. Then you use 2, -3, -11, and 6. And of course, that comes from the coefficients of your function. All right. Now, notice my green lines right here. If it says f of 3 is equal to 0, that means this has to occur. So if that doesn't happen, the problem isn't wrong. Somewhere we went wrong in our calculation. Because if they say 3 is a 0, that means my remainder is 0. And then if I have 6 right here, the only way I can get 0 is if this is -6. So this has to happen if 3 is a 0. So, always use your information to your benefit. It's telling you where the problem has to go. If your calculation doesn't take you there, then somewhere we went wrong in our calculation. So first thing you do is bring down 2. Then 3 times 2 gives me 6. -3 plus 6 is 3. 3 times 3 is 9. -11 plus 9 is -2. And then 3 times -2 is -6. And then 6 minus 6 is 0. Everybody okay before we go to the next step? Make sure we're okay. All right, so we have 2, 3, and -2. Always remember you start off 1 degree or 1 exponent less than what you originally had. Originally, we have 2x cubed. So we're starting off with 2x squared. So now we have a function that we can either factor or use the quadratic formula for. So we have 2x squared plus 3x minus 2. I decided to go ahead and factor 2x minus 1 and x plus 2. Solve those. And we have x is equal to 1/2, x is equal to -2, and then don't forget x equal to 3 is my other solution.
You said you decided to go ahead and factor. So does that mean that there's another thing you could have done instead of factoring?
Quadratic formula. Yep, so you could use the quadratic formula if you wanted, and you still would have got 1/2 and -2.
You just have
So
to write out about 2 more pages worth of notes if you want to do the quadratic formula.
Oh, pessimist one. Oh, pessimist one.
No, sir. I'm
explain to me how this
serious.
magic works. So we have 3 solutions
Yes,
because there's a 3 at the top of that exponential thing, right?
yes,
And we can like factor to solve for 2 of the solutions, but another one of the solutions just pop out of nowhere.
No, it was magically given to us originally, sir.
Yeah, I know that, but like I'm thinking, how do you know that 3 is a 0? You will only know that 1/2 and the other things are 0.
Well, it told us originally. It told us in the
Yeah.
directions. Yeah. So according to this problem, it told us. So
Okay.
we just go with what they gave us. Now, let's say if it just says solve. Next section, we'll talk about what you can do in order to figure out what are your possible options. And then from there, from your possible options, you plug them into your equation like we did this and see if it gets 0. If it gets 0, then it's a solution, a 0. But you will have a list of possible options that you can choose from. And once you find a solution, then now you can use synthetic division to break it down. And then after you break it down, you can break it down again with your quadratic options, your quadratic terms. All right. So Mr. Bracy, is that better?
Yeah.
Okay. Okay.
Yeah, it is.
All right. Somebody said in the chat, let me go back to it. Did we do 3.2? No, we did not. We're gonna come back to it if we have the time, or or maybe not, if I decide that y'all had enough. So we'll see.
Mercy.
So we went from 3.1 to 3.3. All right. Everybody good? Before we try it again. All right. So same process. We have 15x cubed plus 14x squared minus 3x minus 2x. I said minus 2x minus 2 equal to 0. This time they tell us that -1 is a 0. All right. So we're going to follow the same process. We know -1 is a 0 because they told us. Once again, next section we'll see what we would do if they don't necessarily tell us this. But since they tell us that it is a solution in this case, we can use that -1 synthetically to break down 15x cubed plus 14x squared minus 3x minus 2. once again, use the information to your advantage. We know that -1 is a 0, so that means this has to occur. All right, why my pen didn't work? Okay, anyway, it's good now. But anyway, this has to occur. If you end in -2 and it has to be 0 as a remainder, that means the last column has to be a +2 to turn that into a 0. So first step is we bring 15 down. Well, let me say this, don't forget to set it up properly. -1 goes in the box, 15, 14, -3 and -2 comes from, your function. Bring down 15, -1 times 15 is -15. Add the 14, -15 together gives you -1. The -1 times -1 is +1. -3 plus 1 is a -2. Then -1 times -2 is a +2. Add those together and that confirms our 0. And that means we can go to the next step. All right, questions on the breakdown before we go to the next step. All right. So once again, start off with a degree less than what you originally had. Originally, we had x cubed. So now we're starting off with x squared. So we have 15x squared minus x minus 2. Set that equal to 0 and solve. So just like I said before, I didn't mention completing the square. Most people don't run to using the completing the square, but you have 3 options once you have a quadratic equation. You can either factor if possible. If you can't factor, then you always can do the quadratic formula. But if you want, you could do completing square. It's up to you. Either way, you'll still get the same answer. I always lean on factoring. To me, it's the quickest for me. But some, quadratic formula might be quickest for you. It doesn't matter. You'll still get the same answer. So 5x minus 2 and 3x plus 1 are my factors. Set each one of them equal to 0 and solve. So they give you +2 over 5, -1 over 3. And then don't forget that third solution. It's -1. Any problems? Any problems? All right, somebody said something. And why I got to go with them? I don't understand the thought process. If you want to burn the books,
Knowledge is forbidden. We can't have anyone that could possibly write it down later.
Look. If you want to burn the books, feel free. I mean, you got to throw me in the books. Questions? Any questions? Look, I won't say a word. I forgot math. I'll leave it where it at. So just remember that if y'all ever decide to overthrow the kingdom, I'll be quiet. All the math knowledge can stay inside. Questions, concerns, or comments? Oh man, it turned me into a witch now. So, questions, concerns, comments before and let's see. Yeah, we're good to go. Yeah, we straight. Yeah, class. Yeah, we're good. So that's it for this section. If you guys are good, I'm good. Next class, we'll go ahead into 3-4 and roll from there.
Real quick. So this concludes section 3.
3-3. Yep.
Homework, do we have to do 2 and 3? Or just
No, you don't have to do 2. No, you can skip that. If we come back to it, then we'll talk about it. But until then, you're good to go.
So if we don't talk about it, but we do it, do we get extra credit?
Sure.
All right.
Sure. All right. So you guys have a good one. Be safe, and I'll see you next class.
Bye.
All right, take care.
You too.
Burn the witches.
Hey, are you gonna be able to do office hours today? I know you said you had a sick kid.
Yeah, I should be in there. If anything changed, I'll let you know. And I
'Cause
saw
I
your,
had some,
go ahead.
I had some issues with math lab, dude. Like,
That's what I'm about to say. I saw your email and I didn't get a
bruh,
chance to respond to
that
it.
thing was a son of a bitch, man. Like, it literally it was running at like slower than dial-up speed. Like,
Wow.
there's hamsters in a wheel that could have spun this thing faster, and it took me 2.5 hours to do one section, and it wasn't because of my doing the math. It was how long it took to load in between each question.
Wow.
And then finally, because it kicked me out completely Friday, and I could not get back in. I talked to Pearson, like there was nothing else they could do. They're like, see if your professor had a problem, and like it just shut down completely. So that's why I sent you that email. And then late yesterday, it finally started to work a little bit.
Right.
But then I ran into some issues with a couple of questions that I had. But I figured something was up. You're always good about getting back to me on time.
Yeah.
So I figured something was up. No worries. But if you weren't going to be there today, then I wasn't going to try to pop in.
Yeah, I should be. But like I said, if something happens, then I'll shoot you that email and let you know. But
All
I
right,
should
cool.
be in there. Yeah.
Awesome. Thanks, man.
All right, have a good one.
You too.